Welcome to the introductory tutorial for PhotoModeler's points-based projects. In this tutorial, we will work through the basics of setting up and producing a points-based 3D model in PhotoModeler. We start by selecting Points-Based Project from the Getting Started dialog. Browse to the folder where the images are stored and add them to our project. After clicking Next, we see that PhotoModeler has found a matching calibrated camera in our camera library. This was created using the calibration procedure outlined in the calibration tutorial. If a matching calibrated camera was not found, as it has not yet been added to your library, use this pane to locate a project that contains the camera calibration. We will use the Load Camera from Disk option. Hit the Browse button and find a PhotoModeler PMR project file that contains the camera. Our project setup is now complete. We start by double-clicking to open Photo 1, switch to Line Mode, and outline the box. Line Mode can be used to create lines between existing points, or in this case, we create the points and lines at the same time. We are doing an approximate project, so the placement of the marks is not critical, and we can refine them later if we want. This point is a bit hard to see at our current zoom level, so we tap the plus key to zoom in and mark the point. The minus key zooms out. We could also use the mouse scroll wheel to zoom. We are back to the first point. When we get close to that point, the cursor changes to include a selection arrow, indicating the line will snap to that point. We mark the bottom left of the front part of the box, the bottom right, and the last point on the back. Connect this line and right-click to End Draw. This line segment also needs to be created. Right-click to End Draw. Now we can open the second photo, which is taken from the front left of the box. Enter Referencing Mode. We activate Photo 1 and select all points on the photo. The selection causes Photo 1 to become the referencing source. The blue box around the edge indicates that this is now the source. We move over Photo 2 and click on the location corresponding to the point, highlighted in yellow. As we click, a mark is created and referenced to the point in Photo 1. After each click, the highlight automatically advances to the next point. If we were more concerned about accuracy, we could zoom in to create these marks at a more precise location. We mark the back points on the top of the box, and now the bottom two on the front of the box. The minimum number of references has now been met, and automatic processing has run, solving the camera positions for Photo 1 and 2. Solved camera positions are indicated by the cameras on the thumbnails here and on the title bar of the photo. We can open a 3D viewer to see what is being solved. If we turn on camera stations, you can see where their positions have solved. Everything looks good, so we continue adding points, references, and photos. We open the third photo, which is the back of the box, and reference the points from Photo 1 here. We mark point 1 and the rest of the points on the top of the box. The project now has sufficient information to orient Photo 3. As the photo is now oriented, when we go to mark this next point, we see reference helper lines. The point is already marked on two other photos, so we have two lines. If the project is solving correctly, the point's location should be close to the intersection of these lines. The point lies here. The next point cannot be seen on this photo, so we press the Escape key to advance to the next point. The next point is marked on only one photo, so we only have one helper line. We mark it here. We have now referenced all the visible points on photo 1 with photos 2 and 3. The remaining corner cannot be seen on photo 1. We click Clear Source Photo. This allows us to select a new photo as the source for referencing. We go over photo 3 while in Mark Reference mode. Clicking on an existing point will select it. Clicking where no point exists yet will create a new one and select it. We click down to create a new point here. This selects photo 3 as the source. We can then reference this point on photo 2. Another tool for zooming is to hold down the Control key and use the left button to zoom area. When holding Control, the right mouse button allows you to pan. We reference the point here. We open up a 3D view to review the project so far. All corners of the box are now 3D, but we are missing lines to the point we just created during the referencing. We click on Line Mode and add in the 3 missing lines. Lines can be created on photos or in the 3D viewer. We will save this project as wireframe.pmr. This file is included in the tutorial samples if you would like to load the project. We close all of our photos. Now that we have a basic shape, we will add surfaces. We click on the Path Surface tool. There are other surfacing tools which can be used depending on what the surface shape is and what type of objects are used to define it. As with lines, surfaces can be created on photos or in the 3D viewer. We select the top, side, and bottom lines of the box's top to create a surface here. Right-click and select Finish Surface. Surfaces drawn clockwise will face you, and surfaces drawn counterclockwise will face away. You can use the Flip Surface command to reverse the facing direction after a surface has been created. Top line, side line, bottom line, and Finish Surface. You can see the surfaces as they are created in the 3D viewer here. You can see surfaces in photos if we turn on projections. Surfaces are here and here. We'll finish marking the side surface in the photo, and the remaining surfaces can be marked in the 3D viewer. We go to the 3D viewer options, turn off lines and points, and turn on Fast Textures. Fast Textures take the existing photos and map them to the model. This gives you a quick way to preview a model's textures. You can see how the perspective distortion of the photos causes the textures on the front and top to look warped at some view angles. When we switch to Quality Textures, Photo Modeler will remap each pixel of the texture, searching for the best image and creating a new texture map. Here we have a quality textured model, so you can see the texture distortion has been removed. This quality texture model can be exported in various formats for use with other applications. We will save this project as surfaced.pmr. This file is included with the tutorial samples. If our focus has been measurement rather than visualization, we would need to check our project quality and verify our mark placement. One thing we can monitor easily is project's residuals. The residual is the number of pixels the marked point's location differs from its projected 3D location. The largest residual in the project is displayed on the status bar here. The lower this number, the better. Clicking the status bar will open the photo and select the point with the largest residual. We can zoom in and see its marked location is not very well placed. We drag the mark to the correct location. You can review the residuals of all points in your project using a quality point table. We will go through and examine all of our marks to ensure they are well placed. We can hold down Control and use the right mouse button to pan. Or use the scroll bars. All the marks in this photo look good. Another tool we can use is the Alt Zoom tool. Alt Zoom brings up a magnified window of the area around the current mouse location. After checking the placement of our marks, our largest residual is down to 2.05. The rest of the residuals are also low. We can now add a scale to our project. We open up the Scale Rotate dialog and select the Units and Scale tab. Define our units as inches. Select an object of known length. We know this line is 11 inches. We press Define and our scale is set between these points. We do the same thing for the rotation. We'll define the horizontal axis by clicking this point, holding down Shift, selecting the points from left to right, pressing Define. Now do the same thing for vertical. Select a point on the bottom, hold down Shift, select a point on the top, press Define. Press OK, setting the scale and rotation in our project. Our units are now set to inches. Now we can perform measurements. We open up the Measure pane. Select this line. Its length is 6.167 inches. The line we defined as the scale is 11 inches. Because our rotation is defined, when we open up the 3D view, we can specify the view direction. The default is top. We can also change it to the front. You can also measure in the 3D view. This surface is 43.12 square inches. This scale and rotation definition will also be included if we export the model for use in another package. To export, we select File, Exports, Export Model, and choose the file type. In this case, 3D DXF for use in a CAD package. We choose which object types we wish to export. Press OK. Enter in a name for our DXF file. Press Save. The export is now complete, and the DXF file can be used in a CAD program or other 3D package. This concludes the points-based introduction tutorial. We have learned how to start a points-based project, mark and reference points, add lines and surfaces, view textures, add a scale and rotation, perform measurements, and export the data for use with another program.